Okay, so today's lesson, lesson 8, we only have 9 lessons in this unit, so we're almost there. Just so you know where we're headed in terms of an upcoming test, so you can actually start studying now. Our test, I am planning for next Monday, which I hate to do a test on Monday, but because I'm doing more frequent tests in this unit, we can't just add a whole extra day. So it will be on Monday, but we'll spend some time reviewing and not worry about get more math in the lab class that day. So it's still similar to yesterday. Yesterday we did adding and subtracting rational numbers. Today's lesson says applying the properties of operations. By properties, it means things like the commutative property and the associative property. And I'm not requiring you to memorize what those mean, but we'll be using them somewhat to make solving these kinds of problems easier. Our list of standards is still the same. We're still doing standard 1. Okay, so example 1 says the opposite of a sum is the sum of its opposites. And it wants you to explain the meaning of that phrase. The opposite of a sum is the sum of its opposites. I'm going to give you a very specific example to use here. I'm going to pick the number 2. So I'll write the number 2 in here. And then I'm going to use a fraction. I'm going to use the number half. So 2.5. And it asks for the sum. So I'm going to take 2 plus 1/2. What is 2 plus a half? Irene. 2.5. It's 2.5. So 2 plus a half is 2.5. So the sum is 2.5. Now, what would the opposite of 2.5 be, Devin? Negative 2.5. Okay, so this is the opposite of a sum. So that's what they're talking about in this first part. The opposite of a sum. So the opposite of our sum of 2.5 is negative 2.5. Now we're going to take each of the numbers that we started with, and we're going to use their opposites. What's the opposite of 2? Zoe? Negative 2. And what's the opposite of a half? Negative half. If we do negative 2 plus negative half, what do we get? Zoe? Negative 2.5. So this is the opposite of the sum. This one is the sum of the opposites, and they are the same. Now, you're not going to have homework assignments where you have to reproduce this table. The reason I think this is important is because often when people see the number negative 2.5, they get confused and they think that negative 2.5 means negative 2 plus a half, and that's not the case. It should be plus negative half. So it's important that we understand that, because when we're adding a lot of different rational numbers together, we don't want to get confused. We're going to be breaking numbers apart to make it easier to add them together mentally without using a number line, and we don't want to get confused by that. Okay, so let's move on to exercise 1. I'll show you why this is useful. So when we have a string of numbers that we're going to find the sum of like this, there are a number of things that we can do to make this easier. Certainly we could just go in order, and we could add the first 2 numbers together and then find the sum and then add the second 2 numbers together. But there are some numbers that are easier to add together up there than others. Does anyone see what we might be able to add first? Violet?
Negative 2 and 2/5.
Yeah, if we take the 2 fractions that have the same denominator, this 5 here, this would be a good place to start. So what I'm going to do is I'm going to rewrite this as negative 2 2/5 minus 3/5 plus 3 1/4. So I just used a property right now of addition. Does anyone know what that property was? Adria? I used the commutative property. Commutative, the word commute means to travel or to move. So when you commute to work, it means you drive somewhere to work. If you commute with someone else, you drive together. So commutative property means you move them around. So I moved them around. Now, I'm going to do something else. I'm going to take what we just did with finding the sum of the opposites. I'm going to break this up to make it a little bit easier to do. I'm going to call this negative 2 2/5 negative 2 plus negative 2/5. Is everyone okay with what I just did? Now I'm going to also change this minus 3/5 to plus negative 3/5 plus 3 1/4. And that's just using what we just learned, that the sum, the opposite of a sum is the same as the sum of the opposites. So that's why I can do that. Okay, now it's going to be really easy if I add these fractional parts together first. So I'm going to keep my negative 2. What do I get if I do negative 2/5 plus negative 3/5? Katie?
You get 5/5.
Almost. Negative 5/5. I get negative 5/5. What does negative 5/5 reduce to? Elena?
5 or 1, sorry.
Careful, it's negative 5/5, so.
Oh. Wait, negative 1?
Yeah, it's negative 1 because only the top 5 is negative. The bottom's not. We'll learn later about multiplication, but if it's of negative 5/5, it would reduce to negative 1. Okay, so we have negative 2 plus negative 1 plus 3 1/4. Now this is pretty easy to do. I have negative 2 plus negative 1, I need to move up here, is negative 3 plus 3 1/4. If I have negative 3 plus 3 1/4, what is the sum of that? Violet? 1/4, just 1/4. Now I did a lot of work to show you that. I'm going to ask you to show a fair amount of work when you do these at first today, but later on you're going to get good at just doing this mentally. So if I were going to add negative 2 2/5 minus 3/5, I probably wouldn't rewrite it, switching it. I would just look at them and I would do it. But when you're first learning to do these, it's easier if you write everything down. It also makes it easier for me to help you troubleshoot. Okay, let's look at example 2. This number line model is kind of a little harder to see on your paper. Mine has colors, red and black and red and blue. So you might want to just draw a line here to show that this arrow is going in 2 different directions. So this is just showing you, again, this sum of the opposites thing. You can see that 2 plus 2/5 is represented by a single solid arrow. And down here, they break it down as the separate 2 2/5. And then up here again, negative 2 plus 2/5. The opposite of the sum is shown by a single arrow. And then it's broken down into 2 arrows. Don't worry if this seems a little confusing. This isn't my favorite model. The big thing that you need to take away from this is that 2 2/5 means 2 plus 2/5. And if we have negative 2 2/5, both parts of that are negative. So we have negative 2 plus negative 2/5. That's the takeaway from this page. If it helps you to visualize it on the number line, great, but as long as you remember this part, that's what I want you to remember. Okay, we're going to go into exercise 2, which just asks us to rewrite each mixed number as the sum of 2 signed numbers. So we're just going to do just what we did here, how we said that 2 2/5 means 2 plus 2/5, and I'm just going to call on some of you to tell me what these are. So letter A, Devin, how would I write this as the sum of 2 signed numbers?
Negative 9 plus negative 8, and 5/8.
Yes, negative 9 plus negative 5/8. Okay, letter B, Carly.
Negative 2 plus negative 1/2.
Good. And letter C, Reed.
8 plus 12.
Good. Okay, for the next exercise, we're going to do the opposite. We're going to take each sum and write it as a mixed number. Eli, what would letter A be?
-1 and 5/12.
Good. Letter B, Jake.
30 plus 1, or wait, 30 and 1/8.
30 and 1/8. Good. And letter C, Jimmy.
17 and 1/9. 17 and 1/9.
Oh, there's something missing from what you said.
Oh, negative.
Negative, there we go. Negative 17 and 1/9. I'm having one of these days where all my numbers are running together. Okay, pretty easy. Everybody okay with that? Okay, now let's look at another example of how we could use this. This one is phrased as a word problem. Mr. Mitchell, I know a Mr. Mitchell. Mr. Mitchell lost 10 pounds over the summer by jogging each week. The Mr. Mitchell that I know did not go jogging this summer. But he's a skinny guy, the Mr. Mitchell I know, so he doesn't need to. By winter, he had gained 5 1/8 pounds. Represent this situation with an expression involving signed numbers. What is the overall change in Mr. Mitchell's weight? Okay, first of all, let's decide how we would write an expression to represent this. Let's see. Eve, can you come up with an expression to represent this?
Would it be negative 10
Negative 10, good, because he lost 10 pounds, so we would say negative 10, okay?
plus
Uh-huh.
5 and 1?
Good. Plus 5 and 1/8. So if we turn this into an equation and solve it, then we're going to find the overall change in Mr. Mitchell's weight. Now, using this idea of breaking up our mixed numbers, let's try doing that. So we're going to keep the negative 10 the same. Grace, how would I write 5 and 1/8 as a sum?
5 plus 1/8.
Okay, so I'm going to do plus 5 plus 1/8. Now I can add my whole numbers together. Reagan, what do I get when I do negative 10 plus 5? No, careful, signs are different, different signs. Negative 5. Different signs subtract, keep the sign of the larger number. So now we have negative 5 plus 1/8. So we can imagine being at negative 5 on the number line and then just moving to the right 1/8 of a unit, of a whole unit. So what would we end up at? Adria?
4 7/8.
You're missing a little piece to that? Negative 4 7/8. Good. Negative 4 7/8. So we would say that the overall change was a decrease of, do I need to use the negative sign here? No, because the word decrease is filling in our negative sign. Decrease of 4 7/8 pounds. Or you could say, another way you could say this is the overall change was negative 4 7/8 pounds. That would also be correct. As long as you don't use the negative sign and a word like decrease, you're good. Okay, any questions about this? Okay, one more example that we're going to look at. I almost considered skipping this one because it is done to such an extreme, but I want us to look at each step of this problem. It asks you to justify each of, well, actually, I'm going to read the whole thing to you. Jamal is completing a math problem and represents the expression negative 5 5/7 plus 8 minus 3 2/7 with a single rational number as shown in the steps below. Justify each of Jamal's steps, then show another way to solve the problem. So we're going to mostly focus on that part with justifying his steps. I might do this problem differently than Jamal did. You might do this problem differently than Jamal did. There's no one way. We don't have to say the steps have to be in this order. But we're going to look at what he did and decide why he did each thing and why he could do that from a mathematical standpoint. Okay, So remember, here's our original over here. I wish they had put the original right above the rest of it so we could kind of see as we go from place to place. So if we look at the first one and then we look at the second one, Ross, what's different about the second one than the original?
They put the 3 and 2 sevens in parentheses,
Okay, why could they do that?
and then they also do the subtraction.
Okay, so they changed the subtraction to addition. So why could he do that? Why was that okay to do?
I'm not sure.
Remember our song? Subtracting is the same as
Adding
adding the opposite. That would be the reason he could do that, because up here he had subtraction. Whoops, I'm writing in white. That's not helpful. Here we had, still writing in white. Hang on. There we go. So up here we had subtraction. Down here we have adding the opposite. So for this step, you can just say subtracting is the same as adding the opposite. Okay, now look at what happens between this step and the next step. Sky, what changed in this problem? Bless you.
They switched 8 and 2 and 8 and 3 and 2 sevens.
Good, good. So these numbers switched places. Do you remember the name of the property that allows us to do that? Commutative, good. So that's because of the commutative property of addition. I'm just going to write commutative property. There's technically the commutative property of addition. There's also a commutative property of multiplication. All right, what happened in the next step, Taryn? Just explain it as best you can. You don't have to have the correct. Good. Okay, good. So the way you explained it was just fine. So they separated the numbers. They separated -5 and 5/7 to make it -5 plus -5/7, and then they separated this one as well. What allows us to do that? What did we learn today? Look on the first page of your notes. The first heading, what did it say? Oh. Yep, the opposite of a sum is the same as its opposite. So I'm just going to abbreviate a little bit here. The opposite of a sum equals the sum of the opposites. Okay, next step. Kaylin, what happened in the next step?
They added they switched 2 sevens.
Good. They switched these, and what property allows us to switch things around? Yep, you got it, commutative. So he did the commutative property again. Okay, Adria, what happened in the next step?
They added -5/7 and -2/7 together.
Okay, to get what?
-1.
Good. So these two numbers together became -1. Do you know what the name of the property is that allows us, we don't have to add in the same order that they are here. We can add, so instead of adding -5 plus -5/7, we can add these first. Do you know what the name of that property is? No, it's not commutative. Similar. Elena? No, it's not distributive. It's like the other most common one, but I don't know if you guys ever learned it. Violet? It's the associative property. The associative property allows us to group numbers differently, so it's basically saying we could put a parenthesis around these numbers and say, add these first. Associative, I kind of think of it as who you are associating with. So 3 numbers are sitting on a bench together, and instead of the -5 associating with the -5/7, these 2 numbers are associating with each other, and the -5 is just sitting there like, I'm so bored and lonely because no one is talking to me. So that's the associative property that allows us to change the grouping of numbers. All right, gets a little easier from here, I think. Michaela, what happened in the next step?
They group them so that what for the next step you can simplify and get your answer.
Okay, and what specifically did they simplify or combine?
They put the 5 and -1 together to get this.
Good, so they just added the first 2 numbers together to give us -6. So they didn't really use a property of, they just added them in order now.
Would they just simplify?
What's that? Yeah, you could just say simplify, that would be a good. Simplify, and if you wanted to be more specific, you could say simplify by addition. Zoe, what happens in the next step?
They add -6 and -3.
Mm-hmm. So again, they added just the first 2 numbers to give us that number. So again, simplify. And then finally, we have one thing left to do. -9 plus 8 gives us -1. So we're simplifying again till we get all the way to the bottom. And you may remember doing last year order of operations, you know, where you take a problem and you funnel it down. They wrote this or everything's lined up at the left, but if we centered this, it would funnel down to a single answer. Okay, so that was a lot of complicated work to do something you may have been able to do quicker and more simply, and that's okay. That's why it says that you can do this another way. We're not actually going to show another way to solve this problem. What I would like you to do is turn to the back. Yeah.
So could you do it another way in order to justify
Yeah, you could do it a different way and then justify all of your steps.
it? Yeah, like doing it a different way would justify.
Sometimes on tests like the PSSA on open-ended questions, they'll ask you to do this sort of thing. This is a big thing that you guys will have to do when you get to algebra. On the Keystone Algebra test, one of the standards is that you justify steps using properties of operations. So this kind of gives you a preview of that. Okay, the homework that I'm giving you, I'm going to use a pretty color like pink since I'm writing on a black background. The homework that I'm giving you is not from the Eureka Math series. I didn't particularly like the homework assignment for this, although I do like the exit ticket. The homework was, I didn't think, as practical. So this comes from a different work text that I have, that I can make copies of. And it asks you, skip the on your own 1 thing up above. We're not going to worry about that. I want you to look at the on your own 2, where it asks you to solve each of the following problems, and you can use the number line to help you. I want you to try to do these without using the number line and then use the number line to check them. And I would like you to try doing this by breaking up fractions and decimals. So I'm going to do a couple with you. So number 1, we have 2 1/4 plus -1. And I would recommend doing this on separate paper so you have room to write this. What I would like you to do is split this apart into 2 plus 1/4 plus -1. And then you can rewrite it if you want, showing the commutative property would be 2 plus -1 plus 1/4. And then we're going to simplify, funnel it down. 2 plus -1 is 1. Plus 1/4 is 1 and 1/4. And then you can also use your number line to do that and check that as well. So you can start at positive 2 1/4, go down 1 whole unit, and you would end up at 1 1/4. Yes?
So for each problem, you want us to do it like that?
Yes, I want you to write out work and show me how you would do it. The goal in this is to become fluent at doing these in your head, But when we are first doing them, I do want you to write out your steps so we can all see what we're doing. I'm going to do one more with you, and then you will have a little bit of time to work on this. So number 2 has a decimal, and we've not done any with decimals. You can break apart the decimal the same way. It will become -2 plus 1 plus 0.75. So now we can simplify. -2 plus 1 is -1. And if we're at -1 and we go to the right 3/4 of a unit or 0.75, we're going to end up at -0.25. Question?
Can we turn them into fractions if you want to keep it against
You can turn them into fractions if you want. I don't have a problem with that if you prefer working with fractions. Okay, any other questions before? Okay, where's my, here it is.